This is a very common problem that most calculus, if not all calculus students see. What you've got here is an island, and you've got, you want to connect this island to some power. And the power station is down here at B. So how do you run the cable from the power station to the island? Well, you could run it straight down like this and then over, but see, it costs more to run the power cable underwater than it does over land. Or you could run it from the power station right out to the island, but doing so might incur a pretty big underwater cost. So the question is there somewhere between A and B where you could run the cable over land and then out to the power that will minimize the cost of laying that cable? So we could set this up, and we probably will in a later section, but right now we're already given the function. So here's our function right here, and maybe we used Wolfram Alpha to graph this, and what we can do is we can find the value of x. Now here's what x is. X is the distance from that perpendicular point over to where we're going to attach the cable to the land. That's what x is. So what distance should that be? Now if x is 0, we would run the cable right straight down. If x is as big as possible, then we would run it this way. So what x is going to minimize the cost? Well, all we have to do is look at the graph. I'm down here at the graph now. And what's the minimum x? What x causes the minimum value of the function? Looks like it's right in here. Right now, a thing with the graph is I can't tell for sure, but that's a problem with a graph. It's just you get estimates. So what are we going to say here? It looks like maybe, where's the minimum? Maybe right there? That might give me a minimum. Well, I got a little bounced off a little bit. But okay, this is 1,000. I'm looking at maybe, make a guess, 500. All right, so I'm going to guess here that the value of x that makes the cable a minimum is going to be 500 feet, or just probably 500.